Welcome back, everyone. Today's guest is Nick Panhwar. Is that how you say it? Panhwar?
Yeah,
Panhwar?
Panhwar. I mean,
Panhwar?
in my native language, obviously, it's totally different, but that's okay. In English, it's Panhwar.
Panhwar. Okay. He's the CEO of Panhwar Jet. Can you please introduce yourself and tell us a little bit about Panhwar Jet?
Yeah, I'm a co-founder and CEO of Panhwar Jet. We have started building unmanned, all-electric, a long-range cargo aircraft for urgent corporate deliveries, which is happening 4.6 million deliveries every single day. And I'm not
Oh,
talking
wow.
about these ones which are Amazon deliveries or any other ones. So these are happening between corporations, and they are less than a 20 pounds. So our aeroplane is, first of all, has enough range to be a practical aircraft to, do these kind of deliveries.
Got you. So you shifted focus towards remotely or operated cargo. What did you learn from the early long-range electric bird concept that made the current thesis stronger?
So I go even a little bit back as well. We, like all other, silly entrepreneur, we made mistakes. We
Mm,
went into passenger aircraft, like
mm,
everybody was going there. And then we were halfway through. Then we got one advisor on board, and he said that, why you guys are doing passenger aircraft, why not cargo aircraft? Because first of all, it's very expensive to build passenger aircraft, even though we are okay, to raise the money and then you can build it, not a big deal. But your FA certification and all other legalities and all these things, they are very expensive and they are very time consuming compared to the cargo because there are no human lives involved. So it's less complicated and it costs less. And then when we looked at it, we did a little bit more research about it. What we found out that, less than 20 pounds per shipment, and there are about 4.6 million deliveries happening every single day in the United States.
mm,
They need to be moved from one place to another within 1,000-mile range. So we thought, okay, rather than building a big aeroplane, why not we just build which actually serve this kind of a market because this type of market is served by either trucks and they cost a lot of money or the big airplanes and again they cost a lot of money. So when we looked at it, then we were already working on it. One of our founder, she was already working on unmanned stuff, and which we thought that, we're gonna go in about next 2 years or something. But then turned out to be that if we make it unmanned, the certification cost and the time comes down almost 80% because now there is no human life at all. There's no pilot, nothing whatsoever. And since, this is obviously electric airplane, and does not have a fuel, it means it's not going to burn or it's not going to burn down anything if it falls on the ground, if God forbid. So all these things we learned a lot, uh, you know, about the airplanes that, hey, why we are going after the market, which has no money, because business is all about profit, right? It's not
yeah.
about you build a cool product. I can build an awesome product for you which probably has no use other than the kids play with them,
Mm,
right? So our main thing is that hey, we need to build something which works in the real life, which solves the problem, gives a practical solution to any niche market,
mm,
and it's not cost crazy. It must be cost effective. So, like you put it this way, now the unmanned aircraft that we are building, it carries up to 350 pounds, and it only costs us to build about $30,000.
yeah.
So it means now we don't have to raise a lot of money. We don't have to go through a crazy amount of certification and processes and everything. So it was all win-win for us.
Awesome. Can you walk us through the propulsion stack? Which parts are truly proprietary, and what are you buying versus building?
Yeah. So obviously, at the moment, reason you don't see electric aeroplanes flying up in the sky because none of them has been able to build a practical aircraft. Practical aircraft means flying 25 minutes or 30 minutes is not practical, right?
Mm,
They need to fly a little bit longer. So what we decided to do is, and that was my first thing that, hey, yes, let's go and build the electric aeroplanes, but there's no point either I wait about another 12 years for the batteries to get better, or I only fly for 15 minutes or 20 minutes or 30 minutes. That's not good enough. So we started working on propulsion system. So there are two parts of the propulsion system. One part is onboard power generation system, and most of the people think it's a kind of a, what do they call it? Some science fiction or something. And obviously, we do not discuss about these things because it's very proprietary and everything, all stuff.
mm,
And then they think that we are breaking the laws of physics and everything. But obviously, we always arrange a lot of events where we display our propulsion system, including onboard power generation system and everything. So obviously, the people, those who have seen, they know it's working. That's why they put the money in, and the people, those who haven't seen, they feel free to make any assumptions they want, right, about breaking the laws of physics and everything. So we said putting the heavy battery is not going to solve the problem. So the first thing that we thought about is that, hey, let's generate the electricity on board so we can extend. First of all, we reduce the weight of the aeroplane, and secondly, we enhance the actually flight time. So we started working on onboard power generation system, and then obviously, if I ask you, you take any BMW engine and put it
yeah,
into aeroplane, it's not going to work, is it?
no,
Because
so no.
yeah, and that's exactly what every electric aeroplane company is doing. They're buying these industrial electric motors,
Mm,
and they're thinking that, oh, this is the motor for electric aeroplane. So the basic concept for this is, you know, you have the battery, you have an electric motor, boom, that's your electric aeroplane.
mm,
I'm afraid it's a lot more complicated than that,
yeah,
which, I mean, I'm not saying we are the most smartest engineers and everything, but the question here is that, hey, you pick up electric aeroplane and you telling me you're going to build one. First of all, you accept that the batteries are too heavy, and then you still want to use them. And the second part is that your electric motor, right? So what we did is that we actually built in-house a custom electric motor, which
mm,
is purely for our aeroplane, right? That okay, what are the things that we need in electric aeroplane, and then we took care of all those things while designing the things. So now the good news is that our onboard power generation system, along with the propulsion system, we've been testing it, and we have done over 1,000 hours. So that's where we are very confident that when we put in any aeroplane, right, that aeroplane is going to fly longer because the amount of energy that we use to fly the aeroplane is way less. And plus, on top of that, we are generating the electricity as well ourselves on board.
got you. So we've seen big names delay or fold certification takes longer. Capital dries up, secondary markets don't exist yet. Which three traps will kill an aviation startup first?
So there are three things that which I believe is going to kill most of the startups. First of
Hmm.
all, their business model, right?
Yeah.
So let's talk about the business model. You telling me you're going to build $4 million worth of aeroplane, which is going to only carry four passengers and fly for 30 minutes within the city, and they're going to pay you enough to actually, break even the cost Forget about all the infrastructure costs. We are not even talking about that part. We are
Mm-hmm.
talking about just the building cost. The building cost on average is a $4 million. So
Yep.
it takes them about 11 to 12 years before they break even, right? So the
Yeah.
business model is totally flawed here, right?
Yeah.
I mean, when I talk about the Panama Jet, you have a 30,000 aeroplane, right? $30,000 worth of aeroplane. And even if you carry about five deliveries, 20 pounds less, and each delivery is about $500 to $800 per delivery and everything, how long
Mm-hmm.
is it going to take us? 1 month, 2 months to break even, right? So first of all, the business model is flawed. The second and most important part is that, electric airplane is all about replacing your current aeroplane, right?
Yep.
Otherwise, you have the aeroplane, you have the solution available. And if your solution is not good enough, then there is no solution. If the aeroplane can take this freight or passenger and fly about 1,000 miles, that solves your problem. But if you're building something which doesn't even solve the problem, that's not the product. That's
Mm-hmm.
a good looking, awesome, cool toy, but that is not the product.
Mm-hmm.
That's what I believe. And the third and most important part here is that, in order to build any aeroplane, there are a lot of innovations needed, right?
Mm-hmm.
You can't just pick up the electric motors from there here, and your blades from this, and do this and put them together and everything. No, it's all about innovation. We have even developed our own blades, right? Because the blades they are available, they are developed for engines, not for the electric motor, right? I mean, I can go get into the engineering jargon and everything, but obviously, I'm sure that you guys won't want to listen to that. So my simple thing here is that eh, if you're building something which is pure innovation, you got to do a lot of innovations in that before you build something. Unfortunately, I don't see the basic thing is all about your engine of the airplane, right?
Mm-hmm.
Look at the Honda Jet. They took long time, about I think if I remember correctly, 7 to 8 years to do the certification. Not because they couldn't build the airplane, because they couldn't find the right engine and certify it,
Mm-hmm.
right? So when you build the aeroplane, the first thing you think about is, hey, what type of engine I'm going to use? And that's the basic principle. That's the basic principle of the any aeroplane that you want to build, right? The first thing you need to know is, hey, my mission, how heavy this aeroplane is, how far this is going to fly and everything. Okay, I want this aeroplane does these things. And I have this engine available, which I'm going to put in. But in electric aeroplanes, where's the engine? Electric
Mm-hmm.
motors.
Yep.
Who's building the electric motors? Industrial electric motors, they're not going to work.
Mm-hmm.
That's what we have learned so far.
So who's surviving?
I think they have understood, uh, after spending about millions of dollars, they have understood what they have to do. So the only option for them is that, either they build a pure electric propulsion system,
Mm-hmm.
right? Or the second option for them is, which is not really an option, which takes you to the death penalty anyway, which is wait for the batteries for 10 more years or 12 more years before the batteries have a better density so you can fly faster and longer. That's all it is. But the most important part is that, you need to have a propulsion system to take your aeroplane, fly longer. If you don't have a propulsion system, you can make a cool aeroplane. eVTOL, there's no doubt, they have developed a complicated software, right? Complicated stuff. It can fly. We can see it. It can fly and everything. But here's the deal. The deal is, FAA wants you to have extra time, you know, and at least 45 minutes of the time that if there anything happens to this and all these things. So there are a lot of things which at the moment, you know, is just not certifiable for them. If they continue to a traditional path, right? The, and the problem here is that another problem is that, and one of the biggest criticism that we faced, hey, you both founders are not aerospace engineers. Oh
mm,
yeah, we are not aerospace engineer. That's why we can think out of the box,
mm,
right? And they think that, any aerospace engineer who knows how to design the aeroplane can actually build electric aeroplane. No, this doesn't. And if this was the case, we had the electric aeroplanes 5 years ago.
yeah.
Right? Just give me 2 seconds. My battery is dying, so let me.
Okay.
Uh, right. Okay. So make sure laptop is okay. Okay. Perfect. Right. So yeah, my simple point here is that you need a lot more innovation.
Mm,
You know, to bring the practical electric aeroplane. Do we have electric airplanes? Yes, we do. Of course, we do. Jobies have. You can fly for 10 minutes or 15 minutes, and it doesn't take you anywhere. Yes, you have the toys, but you don't have a practical product. Put it this way. Make sense?
makes perfect sense. Yeah. So paint 2027 for me. Where is Panhwar Jet flying? How many aircraft will clients, and what's the headline metric you want the industry to judge for?
So for us at the moment, we have already built all the parts for the aeroplane and everything,
Hmm.
and we have just kept it there. Now we are testing all our control systems and our propulsion system and everything, and we
Hmm.
are hoping to start the certification process early next year, right?
Okay.
And we believe that, because it's just a electric, right? And FAA is nothing other than they want you to give them a redundancies, right?
Mm,
It's all about redundancies. FAA is all about redundancies, nothing more than that. Right. So what we are doing is that, we are putting about 3 electric motors in each propulsion system,
mm,
right? It means if one goes down, two goes down, we still have electric motor available to take the aeroplane safely and land, right? Obviously, so that's our redundancy. Second part is that, our battery, we still use batteries, because obviously, our onboard power generation system is, and the way it works is that we still need the batteries. But our batteries are very small. So either we draw from the battery and we charge battery using our onboard power generation system, or when it up in the air, then we provide, direct, power to our electric motors through power generation system,
mm,
right? So now the question here is that, do we have a redundancy there? Of course, we have a redundancy here, right? If our onboard power generation for some reason fail, right? We still have a battery to power the electric motors to safely bring the aeroplane down, all the stuff. So all these redundancies and safeties we have in mind, right? And the good news, here's the good news, Daniel, that we need to understand, and why people not don't seem to understand here is that, when we talk about our timelines and everything, our main thing here is that, when you just want to show that you have an aeroplane to your investors and you just want to show them a product and you make them excited, then you just build an aeroplane, right? You don't care about FS certification. You don't care about anything else. What all you want is that, hey, I put the plane up in the air. I'm good. How many companies put the plane up in the air? And then it's been several years they haven't been able to increase of one extra single mile of a flying, right?
mm.
So it's not about, for us, it's not about that. We know aeroplanes can fly. You
Yeah.
know, we know there are, a lot of CFDs and, these softwares are available which can tell you right away that, yes, once you assemble the aeroplane like this, and these are your wings, and this is all the things are, your aeroplane will fly. So we don't have to show that the aeroplane fly. What we show here is our propulsion system continuously run and provide amount of thrust is required to put that aeroplane up in the air. And that's what we show to people. Hey, we are continuously, our propulsion system is running for about 7 to 8 hours, right?
mm,
And this is the amount of thrust that we are generating. And that's
mm,
all you need for any aeroplane. So for us is our plan is to go the certification for the propulsion system and everything. And
mm,
because our aeroplane is just very basic, very simple, because this is the place that we did not want to do anything. We just want to build a normal aeroplane so we can just fly. You know, do you need a sexy aeroplane if you're going to put cargo in that? Right?
no,
You don't need it, right? You don't need it if the passengers are sitting in there. Then you
mm,
spend about a $2 million for your interior. In here, we
mm,
don't have to spend a single dollar on the interior. So our timeline is that by end of 2026, we want to go for IPO first, and we also want to put some aeroplanes into operation. Right? It may not be in United States that we doing it. It may be we are talking about in the Middle East or in China. We will be putting these aeroplanes in place because we are working with them as well. We are working, and we understand that the certification over there is different, and in here is different. So we believe that because obviously we have received the biggest contract from a Middle Eastern company, so our main focus is to deliver the aeroplanes to them. So that's the reason that we are looking that make sure that we get the certification as soon as possible, right? And put the aeroplanes in the operation. So we say by 2027, we're looking to make this company a lot more profitable
mm.
and put at least about 100 aeroplanes into operation.
All right. Well, those are all the questions I have for you. I appreciate you having me on. This was Nick Panhwar with Panhwar Jet. I'm going to go ahead and end the podcast.